Okay, so go ahead and scroll down. You can, all this information below that is just what we did here, with finding these values. So flip to the next page. This image here, is what you will get on your exam. Okay, so you'll have the 34, 13.5, all these guys. Okay, you won't have the 68, 95, 99.7, but you know, you can easily find those by adding things together, right? Okay, so we're just going to do a couple quick examples. A company has a policy of retiring company cars. This policy looks at the number of miles driven, purpose of trip, style of car, and other features. The distribution of the number of months in service for the fleet of cars is bell-shaped and has a mean of 54 months and a standard deviation of 8 months. Using the 68, 95, 99.7 rule, what is the approximate percentage of cars that remain in service between 62 and 78 months? Okay, so we need to figure out how many standard deviations away 62 and 78 months are. So I'm just going to kind of draw the axis of our bell curve. So I'm going to put our mean on here, which is 54. Okay, 62 and 78 are higher than 54. So I'm just going to fill in the right side of my bell curve with my 3 standard deviations. Okay, a standard deviation is 8 months. So I'm going to add 8 to each of these. So 54 plus 8 gives me 62. I get 70 and 78. Okay, and again, that's just our bell curve. Well, that was terrible. Pretend that looks like a bell curve. Okay, but we're just looking at the axis because we need to figure out where 62 to 78 is. Okay, so looking at our graph up here, 62 to 78 is the second chunk and the third chunk, right? We're one standard deviation away from the mean to get to 62. Okay, so we need to figure out what percentage of our data is in there. So I'm just going to add 13.5 and 2.35 together. And that gives me 15.85%. Okay. Next one, the distribution of weights for newborn babies is approximately normally distributed with a mean of 7.3 pounds. Excuse me. And a standard deviation of 0.8 pounds. Use the empirical rule to answer the following. What percent of newborn babies weigh more than 8.1 pounds? So again, we need to kind of label our axis. So I'm just going to use the image they put down here, and we can draw on that one. So our mean is 7.3, and then our standard deviation is 0.8. So I'm going to add and subtract that to get the rest of the values. So we get 8.1, 8.9, and 9.7 going up, and then let's go down as well. 6.5, 5.7, and 4.9. Okay, so for part A, we want what percent of newborn babies weigh more than 8.1 pounds. So 8.1 pounds, that's right here, right? We want more than. So I'm going to add everything to the right of that. So 13.5 plus 2.35 plus 0.15. Okay, if we add those together, we get 16%. Okay, take a second, try part B on your own. Okay, for part B, we want less than 5.7 pounds. So that's right here. Less than would be the left side. So 0.15 plus 2.35, which gives you 2.5%. Okay. All right, flip to the next page. We have 3 more examples to do, and then we'll be done. Okay. The heights of Japanese adult females are normally distributed with a mean of 158 centimeters and a standard deviation of 7.1 centimeters. Find the range of heights that can contain approximately 99.7% of this population. So 99.7%, we can go back up to our graph and look at that. That's this big section, right? Excuse me. So that goes 3 standard deviations out both ways. Okay, so what it's asking here is basically for us to go backwards what we did here, right? It gave us a little range and we found the percentage. Right now it's giving us the percentage and we need to find our range. So since 99.7 is 3 standard deviations out, then we're just going to go 3 standard deviations out from the mean in both directions. So for our low end of our little range, we would take the mean 158, and then we're going to subtract 7.1 3 times. So I'm just going to write it as 3 times 7.1. Okay, and if you type that in your calculator, you get 136.7. Okay, and now to find the upper or the high number, we're going to do the same thing, but I'm going to do a plus. Okay, and again, this is just going 3 standard deviations up, and that gives me 179.3. So my range would be from 136.7 to 179.3. Okay, let's look at this next one. The height of Dutch adult males are normally distributed with a mean of 5 feet and 11.3 inches and a standard deviation of 2.9 inches. Find the range of heights that contain approximately 68% of this population. So 68%, again, you can flip back and look at that original bell curve, but that's going to be 1 standard deviation away from the mean, again in both directions. So for our low score, we're going to start with our mean. We have 5 feet, 11.3 inches. Okay, and then I'm going to subtract, because we're going down, 2.9 inches. Okay, so if you subtract the inches, that leaves us with 5 feet and 8.4 inches. Okay, now we're going to go the opposite direction and find the high end of our range. So again, 5 feet, 11.3 inches plus 2.9 inches equals, this one's a little bit tricky because when you add 11.3 and 2.9 inches together, you get 14.2 inches, which is greater than a foot, right? So that means we're going to go from 5 feet to 6 feet, and then I'm just going to subtract 12 inches from the 14.2, and that is going to leave me with 2.2. So we have 2.2 inches, 6 feet and 2.2 inches. Okay, and that is our range for that one. Okay, I want you guys to try this last one by yourself, but before you do that, when it asks what is a normal range for this population, a normal range is about 95% of the population, okay? And that's 2 standard deviations away from the mean. Okay, so do this last one, 2 standard deviations away from the mean, and then I'll give you the answer. Okay, so for our low score, we start with our mean, which is 106, and I'm going to go down 2 standard deviations, which is 9. So that gives me 88. Okay, high is the same thing, but I'm going up 2 standard deviations, which gives me 124. So 88 to 124. Okay, that's it for today.